Greetings, everyone. Let's talk about more of section 2.6. Number 14 is on the list, and I'm not going to actually write much down, if anything, for this, because you have at least two examples in your notes of this type of problem. So I'll just tell you what you need to do, or refer to them, and go forward. If a rock is thrown upward on the planet Mars with a velocity of 10 meters per second, its height in meters after t seconds is given by this function h, 10t minus 1.86 t squared. We had two similar problems to this in our notes, and you should go find them if you're confused on this problem here. Both of those problems are different from this in two respects. One, the object was being dropped near the Earth's surface, which in here it's being thrown upward, but that's inconsequential because they gave you the height function. They gave you the position function here. It's being thrown up at 10 meters per second. That's why it's 10t. In our notes, with it being dropped, the initial velocity was 0. So it ended up being 0 times t, or that term just disappeared in both of those cases. The other thing is the units. Here we're using meters per second. Uh, Actually, we did that on one problem, so I guess it's not really different in regards. One, we did feet per second. One, we did meters per second, if I remember correctly. Mars is different, but we did this problem, or very similar problems. So to find the velocity of the rock after 1 second in part A, and in part B, to find the velocity of the rock after t equals a seconds, or when t equals a, you just need to take the derivative. In part B, you'll plug in a as the value, and then in part A, you'll plug in 1 for a. When you do that, I would do part B first, and then go back later and plug 1 in for the letter A, and you'll get the answer. But just take the derivative, take the limit as lowercase h goes to 0, this case, capital H of a plus h minus capital H of a over lowercase h, and just do the process. You know how to do this. We've done it so many times now that should be able to do it. For part C, when will the rock hit the surface? We answered that question too. That means the height is going to be 0. So you'll set your function h up there equal to 0 and solve. You'll get two values of t, one which doesn't make any sense, and the other which will be valid. Um, Actually, one of the values will be when it's being thrown from the surface, and so actually it does make sense. That's just the beginning point, but that's not the one you're looking for. It'll be the other one. So set h equal to 0 and solve. And then for D, with what velocity will the rock hit the surface? You'll take your answer to part C, you'll plug it into your result for part B, and then that'll be it. And again, we did this question a couple times in our notes, so that's why I'm not writing anything down, as I want you to go look at your notes. I've told you what to do. Now go write it up. Number 17 is next on the list. It says for the function g whose graph is given, arrange the following numbers in increasing order and explain your reasoning. So we want smallest to largest. 0 is just the number 0, so that's wherever. Let's see what g prime of 2 is. What you have to do is you have to interpret what that means graphically. G prime of negative 2, well, g prime is the derivative. The derivative at a point tells us the slope of the tangent line to the graph of g at negative 2. So if I was to actually draw in a tangent line over here, I think I'm in the right mode where I could do that. I'll do my, whoops. I'm a little bit off. I missed a little bit, but it's close. It's parallel, so I'll just leave it there. That's the slope of the tangent line. What kind of number is that? It's a positive number. So that's going to be bigger than 0 because positive numbers are bigger than 0. So in your order right now, because we're going in increasing order, all you know is something about these two so far. 0 goes first, and then g prime of negative 2 would come second because that's increasing order. What about g prime of 0? So we would need the slope of the tangent line here at 0, which is obviously a negative number. And so g prime of 0 would go first in our list, then 0, then g prime of negative 2. Now we're going to check g prime of 2. It's back to being positive. Okay, so where does it go in our list? Well, it's not negative. G prime of 0 still goes first, then 0, because this positive number is bigger than that. The question is, would after 0, would g prime of negative 2 come after 0, or would g prime of 2 come after 0? In other words, which is smaller, because this smaller one comes first. Look at the slopes here. Is this larger or smaller than this one? You should be able to tell. And then you put them in the right order. And then do the same thing for g of 4. Look at this. Draw a little tangent line or something close to it and tell me, well, it's going to be positive. Is it larger or smaller than g prime of negative 2? Is it larger or smaller than g prime of 2? Is it larger than smaller than g prime? That's it. Just that, because we already know where g prime of 0 sits. So that's what you got to do. Just put them in the right order based on an approximation for how their slopes compare. Next on our list is number 18. It says to find an equation of the tangent line to the graph of y equals g of x. At x equals 5 if g of 5 equals negative 3 and g prime of 5 is equal to 4. Ladies and gentlemen, that is not a hard question. If you had trouble with that one, then you're missing some of the ideas that we have here. And I'm not going to write the answer down for you, but I gave you in your notes to find the equation of the tangent line. It's y equals f prime of a times x minus a plus f of a. They just changed it to g as the name of the function instead of f, and they changed the a to a 5. So just go put they gave you all of those pieces. They gave you g prime of 5, they gave you 5, they gave you g of 5. Go plug them in. That's it. That's the easiest question in the entire textbook, ladies and gentlemen. It doesn't get much easier than that. So I think that's the easiest. Number 19 is next on our list. If an equation of the tangent line to the curve y equals f of x at the point where a equals 2 is y equals 4x minus 5, find f of 2 and find f prime of 2. We're going to use the same idea over here. So in terms of 2, f prime of 2, y is equal to f prime of 2 times x minus 2 plus f of 2. That's what the equation is going to look like. And then I got to go back over here. We know that this is going to equal 4x. Was it plus 5 or minus 5? Minus 5. So what does that tell us? That those have to be the same thing. All of this has to be all of this. Now there's some simplification that has to happen here, but there's certain things that should be obvious to us. Like for instance, this is the slope. The slope of that is 4. So f prime of 2 is 4. Okay. Now the constant negative 5 is not f of 2 because if I distribute this on this side, I'll get f prime of 2 times x. And then it'll be plus negative 2 times f prime of 2. What I distribute here, I'm just being a little bit deliberate in that. And then it's going to be plus f of 2. That's how all of this equals, or what all this equals, okay? This is the 4x part. This over here is the negative 5 part, okay? You know what this is. We just said that that's 4. So plug 4 in for that. Set all of this equal to 5, rather negative 5, and then go solve for f of 2. Oh, let's see, how long is this video? It's still under 9 minutes. Let's go to number 25, and I don't want to make them too long because the software starts to act funny. 25 says, if capital F of x is that expression there, I think it said 5x over something. 1 plus x squared. It says to find f prime of 2 and use it to find an equation of the tangent line to that curve at 2, 2. Part B says to graph them. That you'll do that on your own. I'm not going to help you with that. So we want f prime of 2, which is our limit as h approaches 0, capital F of 2 plus h minus capital F of 2 over h, which is equal to, I'm not going to run through this entirely for you. You're going to have to do some of the work, but I'll get you started. Now, if I plug in 2, we know the answer should be 2. Why? Because they said it hits the point 2, 2. That was part of it. That's the y coordinate. But if you plug in 2 up here, you get 10 over 5, which is 2. But anyway, all over h. Now it's just algebra. We know that this has to work out to be something, or I don't know if we know that, but it will. So let's get a common denominator, okay, between these two fractions here. So this is 2 over 1, so we'll use this 1 plus 2 plus h squared as our common denominator, which means this first term's numerator remains the same because it already has the correct denominator. This one over here, well, it doesn't have any, it has 1 as the denominator, so we'll have to multiply the numerator times that. Now, what happens to this h down here? As I've said before, that h ends up in the denominator here. That's old stuff. Should be, at least. Up here, we should be multiplying this thing out. I'm hesitant to say that for just a moment because I want to see if there's another way, but I can't see anything at the moment. So let's go ahead and multiply this out. So 10 plus 5h minus 2 times minus 2 times 2 plus h squared. I don't need that parenthesis over there because I distribute. We got h 1 plus 2 plus h quantity squared like this. Now we got algebra. At some point, I'm going to say go off and finish it, but I still feel like I need to help a little bit. Now, if I multiply this out, I get 2 squared, which is 4, and then times negative 2 is minus 8. Then I get 2 times h times another 2, not this 2, because of it's multiplying this out, works out to be 4h times negative 2, so minus 8h, plus h squared times negative 2, so negative 2h squared. And then all of this over the... Notice I'm not expanding it down here in the denominator. I always suggest that you don't. You shouldn't. Negative 2 and negative 8 make 10, but I got 10 right there. So those three things cancel. Everything that's left has a factor of h, which I can cancel with this factor of h here, leaving with the limit as h approaches 0. Again, I'm canceling out an h from those three terms that are left. So 5 minus 8 minus 2h. That h I canceled, so that one's gone. So I don't even need that one set of parentheses like this. Now just let h go to 0. Do the little bit of calculation. You'll know your slope, and then you can go write your equation of your tangent line. I'll make another video for the others later.